Hello there. My name is Mohit Singh. I'm a graduate student at Purdue University. I work with Professor Byung-Hoo Jang. We are from the School of Electrical and Computer Engineering at Purdue University. The topic of my presentation is a live demonstration, high definition personal area tracking system using AC magnetic field. So if we see over the years, there has been a shrinking trend in the focus of research in wireless communication. So we started with big satellite phones. We moved to metropolitan and local wireless area wireless networks, and then we are now moving towards personal and body communication. So for example, a Google Glass, a Bluetooth headset connected to your phone is a good example of body communication. So if we look at the positioning technologies, they show a similar trend. We started with the use of GPS to track you globally, and then we moved to LPS, a tile to track your dog or your lost keychain. Now we are moving towards indoor and body positioning. So indoor positioning is where you can track your position in a big building or on an airport, and you can use location-based services. Whereas body positioning is where you're tracking the parts of your body. So we believe there's an area between the two, which is personal area tracking. When I say personal area, I mean the coverage area of a typical living room. So there are a lot of applications, if you can make this possible, which require personal area tracking. Of course, there are certain latency, accuracy, and precision requirements, but if you can get these, there are a lot of applications which become possible, like virtual reality, motion capture, last mile navigation for drones. So you can use GPS to guide drones, but GPS has a typical error of up to 5 meters. So for the last mile navigation of these drones, you require personal area tracking. Robotics, home automation, indoor navigation is again an extension of personal area tracking. Sports training, so let's say you're practicing for golf. So we can tell, if you can track the golf stick, we can say if your swing is too fast, too slow, or tilted at an angle. Firefighting is another application of personal area tracking. So let me explain you about our setup here. So what we have is a transmitter antenna, which is a reference point, and it generates a beacon signal around it. We have a receiver module, which is equipped with a position sensor, an orientation sensor, a microcontroller, which gets the data from this position and orientation sensors, clubs them, and reports the position. We have the battery. We have a battery to power this module, and we have a Bluetooth and or USB communication unit to communicate with your mobile device. So let me tell you how user experience or using this device would look like. So we put this antenna, we turn it on, it radiates or generates a beacon signal around it. We have this receiver module. We have two receiver modules. One of the receiver module goes in this head mount display tracker, which is a VR display, and the user puts it on his head. So when the user moves around, we can track his or her position in the room. So we can use this to change the scene in the VR application we have running on the mobile device. So for example, we have an app called our solar system. So the app shows our solar system in VR world. When you move around, you move left, you move right, you can get closer to a planet, you can get further away from it, and you can literally walk through a galaxy to have a feel how it looks like. So we have another app called Net of Fish, which is similar to our solar system app, except that here we use our hand module, which replicates your actions in the VR world. So this could be your sword or your gun. In this case, it's your fishing net. So you use this to net a fish in the ocean. So these are a few use cases of this device. Of course, all these applications, and especially the VR application we are demonstrating, it demands a high level of accuracy, precision. It has to be low power, low form factor. It should cover a typical living room to make it possible to use. It has to be low latency, high update rate, and the most important of all is it has to be almost transparent to human body, or it should work in line of sight areas, because VR requires a 360-degree freedom for the user to really feel the virtual reality. So we have a solution which addresses all these points pretty precisely. In this virtual reality app, what we have is we have this lightsaber in Millennium Falcon, when I move around this head mount display, the user's orientation is changing in the VR space. So we can get closer to an object, we can get further, we can like peek in. And then this hand module, it acts as the lightsaber. So you can move it around, and you can actually try to hit back the laser, and we hit the orb back again with its own laser. So it's an interactive game for this application. Me, my advisor, and our co-founder, we have founded a company called AccuPS, which stands for Accurate Positioning System. So we invite you to go to www.accups, which is accups.com, and check out more details. And thanks for watching. This is Mohit Singh from Purdue University.